So in the last video, we spoke about the factors that affected the range of an access point. In this video, we'll talk about the factors which will affect the throughput. Factors which affect the throughput of a WLAN environment, right? Let's take a look at a few of them. One is, of course, the CSMA. In CSMA we use this is basically a medium access method that uses interframe spacing, right? We use physical carrier sense, we use virtual carrier sense, we also use random backoff timer. Okay, so in CSMA, since all of these are used, this really creates a lot of overhead and consumes a lot of bandwidth also, right? This is gonna drastically affect the throughput. In fact, in the networks of 802.11 ABG, I would say ABG, the throughput is somewhere, the medium contention usually is 50% or greater. Okay, so it's 50% or a little higher than that, in fact. In .11n, the overhead or medium contention overhead has reduced to around 20 to 30%. Let's write down here, it's medium contention overhead. What it means is, I'm just going to give you this to you in a very simple language. If my client is connected on a .11a network and connected at 54 Mbps, simply because of the medium contention overhead, the aggregate throughput for one client in an ideal scenario on a single AP is going to be less than 27 Mbps. Approximately, it comes out to be around 23 Mbps or so in practical scenarios. Okay, so this is the power of medium contention overhead, and that's how drastically it changes or reduces the throughput of a wireless client. Now, CSMA is greatly explained in the Wi-Fi fundamentals course. If all these terms are very foreign to you, please, I urge you to go and watch that course as well. You're going to get a lot of insights around what IFS are, physical carrier sense, virtual carrier sense, and random backoff timer, and also medium contention overhead. There's a whole chapter on .11n which I've explained, and yeah, it's definitely worth a look. So go ahead and explore that as well. The second factor that can affect the throughput of a wireless network is the encryption that the clients are using. Encryption, right? So there are encryption basically is an extra overhead that is added to the body of a .11 data frame. So this is the overhead that is added to the data frame of .11. Okay, so let's see how much is really added in WEP. In web encryption that uses the RC4 algorithm, an extra 8 bytes of overhead per frame is added. An extra 8 bytes are added. In TKIP, again, that uses RC4 algorithm, an extra 20 bytes are added to the data frame. Okay, similarly, with the other encryption, CCMP, which uses AES algorithm, approximately 16 bytes of overhead per frame are added. 16 bytes are added, and obviously, needless to say, this is going to consume significant bandwidth, and thus reducing the overall throughput of the wireless client that tries to connect on the Wi-Fi medium. Another factor is the application use, right? So then we all know that different types of applications will require different consumption of bandwidth. We know that voice and data are something that we are aware of. So data and voice scanning or data collection and voice are basically not very bandwidth intensive, honestly. So voice and data will still consume bandwidth, still reduce the throughput, but not too much. applications where you have to do file transfers, right? Application where file transfers are happening, applications where you access, where you need to access the database. Let me write that down properly. Where we have to do database access. These are some applications that require very high bandwidth, and they are very bandwidth intensive applications that will really reduce the throughput of the Wi-Fi client. That is something which we need to keep in mind. And then of course the number of clients on an AP. Number of clients on an AP. We know that RF is or WLAN is a shared medium, or Wi-Fi is a shared medium, right? Is a shared half duplex medium. So the throughput coming out of an access point is shared among all the clients connected on the access point. So more the number of clients, lesser the throughput per client, right? So we want to make sure that we have optimal number of users per AP, right? We don't want to have optimal number of users per AP is something that we want to target. And I did explain in the last video about how many we should have for voice, data and video. So yeah, keep that in mind, and even for location is going to be lesser. And then the last factor is, what I want to discuss the last factor of that, but there are like many other factors also that affect the throughput, is my favorite again. We have spoken about this many times in this course, is layer 2 retransmissions, right? Layer 2 retransmission. So we know that various problems can cause the frames to get corrupted, and once the frames are corrupted, the destination cannot decode the frame, hence the destination will not send an ACK, and the source will think the frame is not delivered, and the source will have to retransmit that frame. Thus, high retransmissions will reduce the throughput, right? So these are some factors which will adversely affect the throughput of the network. Now when you try to troubleshoot a network which is showing such signs that the throughput is getting reduced, throughput is low, you need to keep these things in mind when you start troubleshooting. All these things at the back end, yes, there will be some vendor specific troubleshooting that you will do, but from the overall RF scenario, you need to know these things, that yes, if I am approaching a troubleshooting scenario, these things have to be at the back of my mind, because these things are very commonly seen in the networks, right? A lot of us focus on vendor specific troubleshooting, but we have to also clean the RF. We also have to make sure that the RF is clean, and the all these factors are kept in mind before you take any steps towards the troubleshooting of the network, right? So yeah, this was about it for this chapter. In the next chapter, we will try to cover a few more points around things that can be done around the outdoor WLAN deployments, what factors will affect outdoor wireless networks, and we'll cover those in a bit in the next coming videos. Thank you.